So welcome back to David Arthur Agenda Truth. This is the second video on the IEEE document research paper, Electromagnetic Radiation Due to Cellular, Wi-Fi and Bluetooth Technologies. How safe are we? Corresponding author Mohsen Ghazani. And if you haven't seen part 1, I'd recommend it and I'll put the link below. So I'm going to pick up where we left off. And that is in section 6 here. We just discussed the health risks and hazards of EMR exposure, and now we're going to talk about the protective measures and ambient EMR minimization, which is going to be very, very important for everybody to listen to these words and actually try some of these at home. Let's read through it and then see what we think. Based on the discussion in section 5, which is the health risks, it becomes very clear that the people exposed to EMR must adopt some preventive measures to limit their exposure to harmful radio frequency electromagnetic radiation. In many situations, such as those discussed in section 4, we are exposed to EMR almost daily for prolonged periods of time. While it may not be possible to entirely eliminate such exposure, such as in workplaces, some protective measures could be taken by people to reduce the amount of EMR they absorb and thereby reduce the damage done to their bodies. In this section, we present some techniques which are either based on externally attenuating the EMR before it hits the body, and some techniques based on monitoring and deploying the EMR sources effectively and efficiently, so as to minimize the ambient EMR levels. Ambient meaning in your environment, in your vicinity. The techniques based on external attenuation have to be practiced on an individual level, while the ambient EMR minimization techniques can be practiced on government and society levels only. Okay, so A. Protective measures. EMR absorbing clothes. As a result of the research in the past decade suggesting the dangers of EMR on the body, a variety of EMR absorbing clothing solutions began surfacing the market. Such clothing options incorporate surface metallized fiber woven fabric in their apparels. Surface metallized fiber woven fabric in their apparels. Metals like copper, silver or aluminium are chemically deposited on ordinary knitting fabrics to obtain surface metallized fiber knitted fabric. Such metals are known to attenuate EMR by scattering incident radiation. While many manufacturers do claim a specific EMR absorbing efficacy in decibels over a certain frequency range, it cannot be said for sure whether the attenuation rating claimed by such clothes was obtained through well-designed tests. Such clothes are generally bilayered, where the first layer reflects some of the incident EMR and the second inner layer absorbs the radiation passed through the first layer. The higher the decibel value, greater is the shielding capacity. Most of the materials have a characteristic range of frequencies which they absorb. For example, a product that has an effect of 30 decibels at 1 to 5 GHz would mean that the product blocks 99.9% of radiation in the wavelength range of 1 to 5 GHz, which includes most of the RF EMR encountered commonly: cell phones, Wi-Fi routers and Bluetooth devices. Metals are the best solution to reflect EMR. Hence, such clothing generally has metallic strands or metal silk fibers embedded within them, which reflect incident EMR away from the wearer's body. Metal silk fibers are also blended with regular fabrics to obtain specially designed electromagnetic shielding fabrics which are used to make different clothing products such as curtains and blankets. Chemical deposition processes are also used to form a conductive metal plating on top of regular fabric. In any of the above-mentioned varieties of EMR protective clothing, the shielding capability increases with the amount of metal used in the product. Pregnant women, young infants and children are especially recommended to wear radiation protective clothing due to their higher vulnerability to radiation absorption and damage. Workers who are exposed to abnormally high levels of EMR, such as cell tower repairmen, need specially designed EMR reflective and protective clothing designed specifically for their occupation. So if you're pregnant or you have children, I would definitely consider some clothing. But as they said before, you can't really guarantee the thoroughness of their tests. I suppose you could buy it and test it yourself to really make sure. So, second section, electromagnetic radiation absorbing and reflecting paints. Many households are located very close to cell towers, which have multiple antennas operating on them. The wall facing in the direction of the tower is most exposed to RF EMR. If it is unprotected, i.e. it does not have any absorptive or reflective coating, the people living in such homes are prone to develop EMR-related health issues, as discussed in section 5. One very effective way to prevent high levels of EMR from penetrating the home is to use EMR-absorbing reflecting paints, which are specially designed to absorb, reflect or scatter EMR in the RF frequency range as is emitted by the cell towers. It is desired to achieve high levels of attenuation across a wide frequency range. Pardon me. Materials which have numerically equal values of permittivity and permeability and high loss tangents are more suited to be used in making EMR absorbing paints. The former characteristic guarantees good impedance matching with the air and thus enable incident signals to enter the surface without any reflection. The latter characteristic enables the material to attenuate the EMR rapidly before it enters the home. By using such materials, the reflection is also minimized, so people standing outside the homes are also protected from high power EMR reflected from the walls of the homes. So you don't want to just protect yourself and then endanger others. So people standing outside the homes, yeah, we read that. So the power radiated from cell towers at certain frequencies may be much higher than others. EMR absorbing paints can address this problem as well, because the frequency range at which maximum attenuation is achieved can be set by varying the thickness of the paint applied on the wall. Choosing a thickness to match complex permittivity and permeability can result in a considerable increase in the absorption bandwidth both at normal and oblique incidence of EMR. For example, Folgueras et al. Have prepared two varieties of paints to absorb EMR. Both their formulation have a polyurethane matrix, carbonyl ion powder, 10% W/W, and polyaniline, 10% W/W, are the chemicals dispersed in the matrices of the two formulations respectively by mechanical agitation. The attenuation plots of these paints are shown in Figure 12a and Figure 12b respectively. So let's have a look at those. So that first one on the left there is Figure 12a, that's carbonyl iron paint. And the next one down is polyaniline carbonyl iron paint. And you can see the attenuation in decibels there over certain frequencies. The paint of Figure 12a achieves attenuation of 8 decibels which is 84.1% at 10 GHz, and the paint of figure 12b achieves attenuation of 4 decibels, 60.1% at 12 GHz. Such paints could be used to shield the EMR coming from 5G towers, which are much higher than any RF communication used till date. To ensure the best protection, on-site testing can be done to accurately determine the frequency at which there is maximum radiation, and also the minimum attenuation required to ensure that the residents are protected from any harmful effects. The customers can pass on these specifications to the manufacturer, who can then adjust the chemical composition and also suggest the thickness required according to the customer's needs. That's very good. This will ensure maximum protection and minimum expenditure. So, the frequencies that we're going to want to protect from are anything from sub-gigahertz, anything under 1 gigahertz, right up to 8 gigahertz to 10 gigahertz. The very, very high frequency bandwidths, which is due to be released later, is not, as far as I know, out yet. And these aren't really an issue, and that's why they want to put that kind of thing on your street lights, so it's very, very close to you. So for now, I would consider paint for sub-gig to 10 gig and see what you can do there. And this paper gives a very good, just 2 simple examples. So, number 3, aerogel. This is something I haven't heard of. Aerogels are a class of high-performance electromagnetic radiation absorbing materials designed by fitting several nanosheets of graphene into 3-dimensional structures. Their excellent absorption characteristics is due to their high surface area and dielectric loss. The reflection loss, RL, of a material is a characteristic of the input impedance, which is Z in, and output impedance, ZO. RL, which is reflection loss, and Z in are evaluated as follows. For all you mathematically minded there, you can see the equation here. And there's another equation. That maths is beyond me, so I have no idea what that is. In the above equations, ZO is the impedance of the ER. Does that say R? I'm not sure. Is the complex permittivity. U is the relative complex permittivity, F is the frequency, D is the material thickness, and C is the speed of light. According to fundamental mechanism of electromagnetic absorption, the physics of EMR basically, the most effective absorption would take place when the impedance matching conditions between the material and the free space is achieved. Plots of reflection loss versus frequency, such as this figure 13, which is this top one here, so that's plots of reflection loss, what that graph is, are prepared for various thicknesses of the aerogel material. Such plots may be used to choose the best material for an application, considering into account the most prominent frequency of radiation and the thickness of absorbing material permissible. The frequency at which highest RL occurs varies with the thickness of the aerogel, as can be seen in figure 13. Okay. As the thickness of the aerogel pellet is varied, new phase matching conditions have to be established in order to maintain the reflection loss. Wang al. have prepared ultralight and mechanically strong 3D composite graphene aerogels with the use of waste cigarette filters. Wow. Their composite aerogel showed a minimum reflection loss of 30.53 decibels with a bandwidth of 4.1 GHz. On coating with polypyrrole, a conducting material, the new composite showed minimum reflection loss of 45.12 decibels. Similarly, Xie, I don't know how to say that, AL, prepared a self-assembled ultralight 3D polypyrrole aerogel, a composite which can reach an effective electromagnetic bandwidth of 6.2 GHz with minimum reflection loss of 25 decibels. Wu al. Prepared a sponge-like self-assembled ultralight aerogel which showed a minimum reflection loss of 54.44 decibels with a bandwidth of 6.67 GHz. The above-mentioned aerogels and their absorption characteristics are summarized in Table 6. So let's have a look at Table 6. I mean, this is the kind of good work people are doing. Just hold on. Okay. So we have the name of the aerogel, the bandwidth, the highest reflection loss, and the range for EMR absorption. So the three-dimensional polypyrrole, which is abbreviated 3D-PPY/paraffin, has a bandwidth of 6.2 GHz, and the highest reflection loss is 25 decibels at 3mm pellet at 10 GHz. Then the range for EMR absorption is 7 GHz to 13 GHz. The graphene aerogel composites, which is abbreviated CF@G, has an EA bandwidth of 4.1 GHz, and the highest reflection loss is 30.53 decibels at 2.5mm pellet at 14.6 GHz. So the range for EMR absorption of this is 12 GHz to 16 GHz. The next aerogel we have is graphene aerogel composites with polypyrrole coating, which is abbreviated CF@G@PPY. This has an EA bandwidth of 4.1 GHz. The highest reflection loss is 45.12 decibels at 2.5mm pellet at 14.6 GHz. The range for EMR absorption is 12 GHz to 16 GHz again. The last one is a sponge-like polypyrrole aerogel with reduced graphene oxide. This is S, abbreviated to S-PPY/RGO. This is 6.76 GHz bandwidth. And the highest reflection loss is 54.44 decibels at 3mm pellets at 12.76 GHz. 10.2 GHz to 16.96 GHz is the range for EMR absorption. So you want to check these aerogels out. They sound pretty cool. So just to summarize what that is, aerogels are a class of high-performance electromagnetic radiation absorbing materials designed by fitting nanosheets of graphene into three-dimensional structures. Brilliant. So when people say, what can we do? You know, this is what you can do. Look into aerogels, look into EMR clothing, and look into all of these things which we're going to talk about, as well as cabling everything. So, Section B, Ambient EMR Minimization. The optimal mobile network deployment. With ever-growing consumer demands for telecommunication services and the deployment of 5G technology soon to come, many new base stations will have to be deployed over the already existing 2G, 3G and 4G network. Therefore, it becomes very important to achieve optimal deployment of cellular base stations or wireless access points in order to minimize radiation levels. Compared to most optimization solutions in research, and it lists 4 research solutions there, optimization, so you can check those out in the references, which have considered deployment cost, coverage level and base station capacity and the objective function, Salcedo Sanz al. Have considered an additional criterion, electromagnetic pollution. They have proposed a solution called grouping coral reefs optimization, which is abbreviated GCRO, and demonstrated its effectiveness when applied to a mobile network deployment problem, which is abbreviated MNDP. How many abbreviations do we need to learn? Deriuk et al. Have presented a tool which achieves different levels of optimization for power consumption and human exposure in LTE networks. Pletz et al. Have developed a GenTIC optimization algorithm for wireless local area networks, WLANs, which optimizes the exposure index, EI, taking into account all sources of exposure such as uplink, downlink, and the uplink of other users, realistic duty cycles, while simultaneously ensuring quality of service, QoS, to all users. Chiarivilio, no idea how to say that, al. Have proposed important guidelines to be followed during deployment of 5G base stations in order to achieve EMR-aware 5G networks. These guidelines include modelling of 5G radio technologies, which helps to select the proper configuration of the installed equipment for each considered site, modelling of the generated EMR levels over the territory, which allows for a fine-grained antenna site characterization based on the knowledge of the radiation pattern and the emitted power of each antenna in the site. Integration of current and future EMF limits, modelling of the set of candidate site based on idealized distributions and operator-based constraints. Modelling of 5G traffic demands and quality of service based on spatial and temporal fluctuations that can characterize the radiated power demand, and modelling of 5G network topologies. So as they mentioned earlier, there are steps you can take for yourself. That's the paint, that's the clothing, that's the nanosheets, and being more sensible with how you do things in your own home, cabling things up. And now this other section, they're talking about how industry and government should be working to minimise the risk of radiation from electromagnetism. So 2. Electromagnetic pollution monitoring using wireless sensor networks. With new base stations being installed on a daily basis, monitoring EMR pollution on a real-time basis becomes essential to detect and locate potentially dangerous EMR levels and notify corresponding authorities to ensure safety of nearby people. In this regard, Nu et al. Have proposed an EMR pollution monitoring system using a wireless sensor network, WSN, based framework. Their system uses a genetic algorithm on EMR data acquired from WSN nodes to detect and report any EMR limit violations. The wireless sensor network nodes are deployed uniformly over an area and are equipped with sensors to detect EMR in the frequencies which are most prevalent. It's very difficult to read with all these abbreviations in. Okay, Part 7. Proactive preventive techniques. Certain simple steps can be taken by any individual to avoid EMR exposure, spreading awareness about dangers and health hazards of EMR in schools, hospitals and other areas having sensitive populations such as pregnant women, small children and old people, and giving them simple suggestions based on their surroundings can help a lot of citizens avoid EMR-related health issues without spending resources on integrating and deploying EMR attenuating technology. We have listed few such proactive and common sense measures to minimize unnecessary and needless EMR exposures, keeping in mind various environments and operating conditions. Number 1. In residential places such as homes, at study table and other places where people sit for long periods to use internet, we have Ethernet cable to avoid getting exposed to 2.4 GHz Wi-Fi signal. Many switches to control the power to Wi-Fi router can be installed through the house to readily switch off the Wi-Fi radiation when not in use. The windows can be covered with transparent EMR absorbing reflecting thin film, and outer walls can be painted with EMR absorbing paints. Use of landlines for long talks should be preferred over mobile phones and cordless phones. Use of landlines for long talks should be preferred over mobile phones and cordless phones. Rooms of children below the age of 12 should be particularly safeguarded from EMR as they are more prone to EMR-related health issues. So to summarise what it said there, use your Ethernet cable for your Wi-Fi. If you are going to make calls, use a landline where possible. You can set up your Wi-Fi router so that it switches off when it's not in use. I'm not sure how you do that, but apparently it's possible. And paint the outside of your walls with EMF paint and have transparent films on your windows. So there are so many things all of a sudden. There are so many things you can do. Section 2. In hospitals and medical institutions, it is especially important to implement guidelines regarding EMR safety, as hospitals cater to very sensitive populations such as pregnant women, newborn babies, and unhealthy people. Hospitals should not adopt full Wi-Fi coverage technology. And what do we see? Wi-Fi everywhere. Preferably, they should give Ethernet ports to all the doctors and hospital wards. Government should lay guidelines to not allow deployment of base station or cell tower in near vicinity of hospitals. I actually know 2 5G MIMOs right outside the hospital near where I live. So yes, they should definitely do that. Units for sensitive population like ICU, CCU, NICU and operation theatres should avoid all sorts of devices which use wireless communication, such as wireless incubators and remotely operated instruments. Only those sources of EMR should be used which are meant for medical purposes. Pregnant women should be educated to avoid prolonged use of mobile devices, laptops and other wireless devices. Yes, so if you're pregnant, get that phone off your lap. Get the laptop off your lap. And definitely don't lie down with it on your stomach. In educational institutions, there is a trend to shift to modern technology like wireless projectors in smart classrooms, campus-wide Wi-Fi access, use of digital notebooks, etc. As we have mentioned in Section 5, children are very sensitive to EMR and health issues like autism and impaired mental development are becoming very common among young population. Schools where children spend almost 8 to 10 hours need to minimize the ambient EMR levels inside the classroom by using EMR absorbing paints and window films. School authorities should give special rules and guidelines for high population density zones such as classrooms and school buses, which get really high EMR levels due to everyone using wireless devices simultaneously. If all classrooms cannot be made to comply with EMR safety standards, schools should construct special classrooms to maintain no wireless condition and allow students to opt for it who believe their academic, social or behavioural progress is being hindered by EMR related health issues. That's assuming you informed enough to even consider that. A lot of people still don't even think that EMR causes any health issues. And that's exactly why I'm reading this paper. Section 8. Discussions. Currently employed public exposure limits do not provide sufficient protection to people both in terms of long-term and short-term exposure. The exposure limits specified by IEEE take into account only the thermal effects and not the non-thermal biological effects in determining their limits. The IEEE safe exposure limits for general public for the wireless technologies discussed in this paper are between 4 million microwatts per meter squared, that was for 1G by the way, to 10 million microwatts per meter squared, that's pretty much for all the other Gs, which is several orders of magnitude. Remember, when they say that, it means a goddamn lot. Then the limits prescribed by the Building Biology, AMA, which is the Austrian Medical Association, and the Bioinitiative Standards. While exposure levels within the limits prescribed by IEEE only guarantee safety from thermal effects of EMR exposure, there are numerous scientific studies suggesting that even non-thermal effects pose a significant threat. These non-thermal effects are observed at several orders of magnitude, there's the word again, of radiation lower than those of thermal effects. Along with the thermal and non-thermal effects, several other factors such as frequency, duration of exposure, pulse shaping, power level also contribute to health risks of EMR. It has already been several years since the wireless technologies have been deployed, meaning that the public has already been exposed to a lot of harmful EMR without their knowledge. It may be anticipated that this section of the population will suffer from many of the health hazards discussed in Section 5. It's a polite way of saying, you've been battered with EMR for a long time without your knowledge, and industry have pulled a veil over your eyes, okay, so that you don't look at it. And it may be anticipated, yes. That is saying that you will feel these health hazards, gradually. The more and more you're exposed, the more these health hazards will come along, as I discussed in the previous video. If corrections are not made now, especially when the number of wireless devices are growing exponentially, which leads to an exponential increase in public EMR exposure, the current and future public will be at even greater risks of both known and unknown health hazards. In particular, women, children, and fetus are hypersensitive to EMR, and special care must be taken to protect these groups from both short and long-term exposure. Smartphones, laptops, Wi-Fi routers, Wi-Fi hotspots, and Bluetooth devices such as speakers, earphones, and smartwatches are the most common sources of exposure today. These devices are used extremely in very close proximity. Based on the discussion in Section 4, previous video, It is clear that usage of mobile phones for calling or data streaming, using laptops and smartphones on Wi-Fi networks, using 4G wireless hotspots are especially dangerous. This is a science paper. It's telling you in plain English, this technology is dangerous, especially dangerous. Exposure to radiation from one or two devices, such as a smartwatch on the wrist and a connected smartphone, may result in high radiation levels only near the hand and pocket region. A cumulative and simultaneous exposure to several sources of EMR, such as laptop, smartphone, Wi-Fi router, Bluetooth earphones, smartwatch and speaker, leads to dangerous levels of EMR all throughout the body and must be avoided. While it may take very long for the exposure levels of these devices to be corrected, the users can take some steps to minimize the risk of using these devices. A summary of the recommendations regarding usage of these devices is given in Table 7. There are wired solutions in each of these use cases which can be adopted to greatly minimize EMR exposure. Using hands-free earphones to make phone calls, using LAN cables instead of Wi-Fi, wired earphones, switching off Wi-Fi routers when not in use, maintaining a good distance from the wireless devices are some of the measures to minimize exposure. A twofold approach can be followed to minimize harm from EMR pollution. Firstly, measures can be taken to protect people from the already existing high levels of EMR. Second, proactive prevention techniques can be adopted in environments such as households, schools, and hospitals to greatly minimize EMR exposure. These have been explained in detail in Section 6 and 7 of this paper. Which are the sections I've just read. Both individuals and governments must be aware of this fact, that the current population has already been exposed to dangerous levels of radiation, and the resulting adverse health effects may surface in people at any time. In this regard, proper planning and execution, both on governmental and individual levels, is required to properly handle the breakout of EMR-related health issues in large numbers of people in all areas of the world. Specifically, it must be noted that the radiation in 5G networks is suspected to increase by several folds. It will not only affect regions near cell towers and 5G devices, but all indoor and outdoor environments in the region of coverage. Thus, almost all people in the area of coverage of 5G networks may be exposed to dangerous levels of electromagnetic radiation. Without thorough research and well-designed safety measures in place, widespread deployment of 5G networks could prove to be dangerous. So the final bit of this paper is the conclusions. Well, actually, let's just look at Table 7. Table 7 are the recommendations for using cellular, Wi-Fi and Bluetooth devices. So in light of everything that's been said, everything that's been discussed, these are your takeaways. For cell phones, smartphones on cellular networks, here are the recommendations. Number 1, for network. For internet connectivity, prefer Wi-Fi. If not available, prefer to use 4G networks for both calling and browsing data streaming. For calling, use wired headphones and keep the phone at least 1 meter away while calling. Browsing and video streaming, keep device on a table or a platform at least 50 centimeters away. But I will remind you that even at 50 centimeters away, it only went from extreme concern to major concern. You know, there was only one step down. So 1 meter is actually the best to keep it away. And you can actually see on your phone a meter away. It's not really that far. It's kind of like arm's length. The recommendations for Wi-Fi devices. Prefer smartphones over laptops for casual work such as emails or browsing. Keep smartphone or laptop on a table and operate from an arm's distance, 50 centimeters. You can do more than that. Avoid keeping smartphone in the pocket while it is connected to a Wi-Fi router. Avoid keeping, I'd say keep it on airplane mode all the time if you're not using it. That's what I would say. Avoid keeping laptop on the lap while it is connected to a Wi-Fi router. Wireless ad hoc transfer, stay at least 1 meter away from both sender and receiver. There's your meter thing. 4G wireless hotspot, stay at least 2 meters away from the device while it is active. So these hotspots, they're called hotspots for a reason. It's hot full of electromagnetic radiation. So you've got to stay 2 meters from your device in hotspots. Moving on to Bluetooth devices. Speakers. Bluetooth speakers. Keep speakers at least 25 centimeters away and connected smartphones at least 50 centimeters away. These weren't too bad, you know. Bluetooth speakers, if you have them in somewhere in the room, that's not too bad. Smartwatch, it says, avoid unless absolutely necessary. And let's face it, they're not absolutely necessary. Bluetooth earphones, avoid unless absolutely necessary. Or when you can get cabled ones, then they're not necessary. Okay? No smartwatches, no wireless earphones. Because, as discussed in the previous video, the radiation is extreme concern and must be rectified immediately when compared to the building biology, the AMA, the Austrian Medical Association, and the Bi-Initiative. Those are 3 different bodies there. Not IGNIRC, by the way. So finally, conclusions. People should be made aware that the EMR from using day-to-day cellular Wi-Fi and Bluetooth devices are harmful to human health. Let's read that again. People should be made aware that the electromagnetic radiation from using day-to-day cellular, Wi-Fi and Bluetooth devices are harmful to health. This is in a conclusion of a science paper. Listen to the words. The levels of radiation observed in most cases, such as phone calls, internet browsing on laptops and smartphones using wireless routers and hotspots, Bluetooth smartwatches and smartphones, are unsafe when compared with radiation limits determined by medical bodies. According to current medical literature, various adverse health effects from exposure to RF EMR have been well documented. For now, wireless technologies must be avoided as much as possible. New and innovative wired solutions which provide the same level of user-friendliness should be encouraged. Intervention of government and medical bodies with the main purpose of protecting human health is of utmost necessity to ensure good economic development without compromising the health of the population. Countries must adopt the guidelines suggested by medical bodies which take into account both thermal and non-thermal effects of EMR. At present, all individuals must take preventive and protective measures to protect themselves from harmful EMR exposure. So there we go, that's the end of the paper. And I'll just read who actually made this paper. So we have Naren, is currently pursuing his BE in Electrical and Electronics Engineering and MSc Hons in Physics with the Berlin Institute of Technology and Science, Pelani. He has completed projects on quark gluon plasma, really, superconductivity, hardware security techniques in IoT, and electromagnetic radiation pollution. So I think he would know what he was talking about. His other research interests include IoT, Industry 4, and security provisioning in V2G, UAV, and medical IoT networks. Unupav Elhens is currently pursuing his BE in electronics and instrumentation engineering, and MSc Hons in physics with the Berlin Institute of Technology and Science, Palermo again. He is a recipient of KVPY scholarship granted by the Department of Science and Technology, Government of India, and Sakura Science Scholarship granted by the Japanese Science and Technology Agency. He was a part of the Japan-Asia Youth Exchange Program in Science and was awarded an international linkage degree from Hiroshima University, Japan. His research interests include advanced brain signal processing, Internet of Things, and security in vehicular networks. Advanced brain signal processing, Internet of Things. They're going to link up, aren't they? Vinay Kamala received the BA degree in Electrical and Electronics Engineering and Master's degree in Communication Engineering from the Birla Institute of Technology and Science, Pilani, India, in 2010 and 2013 respectively, and the PhD degree in Electrical and Computer Engineering from the National University of Singapore in 2016. In 2015, he was a visiting researcher with the Autonomous Networks Research Group. So these are all groups we should look at. Autonomous Networks Research Group. We've got to look at these guys. University of Southern California, USA. He's currently an assistant professor in the Department of Electrical and Electronics Engineering, BITS Pilani. His research interests include solar-powered cellular networks, energy efficiency in cellular networks, Internet of Things, and networking issues in cyber-physical systems. And we have the main man, Mohsen Ghuzani. Received the Bachelor's Hons and Master's degrees in Electrical Engineering and the Master's and PhD degrees in Computer Engineering from Syracuse University, New York, USA in 1984, 86, 87 and 1990 respectively. He served as the Associate Vice President of Graduate Studies, Qatar University, the Chair of the Computer Science Department, Western Michigan University, the Chair of the Computer Science Department, University of West Florida. He also served in academic positions with the University of Missouri, Kansas City, University of Colorado Boulder, Syracuse, and Kuwait. He is currently a professor with the Department of Computer Science and Engineering, Qatar University. He is the author of 9 books and more than 400 publications in refereed journals and conferences. This is the kind of guy that's writing this paper. 400 publications in refereed journals. And how many? 9 books. So it's definitely a man worth listening to. His current research interests include wireless communications and mobile computing, computer networks, mobile cloud computing, security and smart grid. But don't want a smart grid. Dr. Ghazani served as a member, a chair and the general chair of a number of international conferences. He currently serves on the editorial boards of several international technical journals and the founder and the editor-in-chief of the Wireless Communications and Mobile Computing Journal. He was selected as the best teaching assistant for 2 consecutive years by Syracuse University. He received the Best Research Award from 3 institutions. He was the chair of the IEEE Communications Society Wireless Technical Committee and the Taos Technical Committee. He guest edited a number of special issues in IEEE journals and magazines. He served as the IEEE Computer Society Distinguished Speaker from 2003 to 2005. I mean, that's some serious work he's done there. Very, very serious work. When I read their bios, I just think, are they really on the side of humanity when they're in these fields of developing all this wireless technology? But then they come out with papers like this, with very decent, helpful advice. So it's to be debated. Here are all the references, which I'm not going to read through, of course, but that's the paper done. And that was this one. So I'll put the link below so you can access the paper, and I'll put links to the 4 different bodies, that's IGNIRP, Building Biology, AMA, which is Austrian Medical Association, and the Bioinitiative. And in my next video I'm going to be doing a quick summary, like a 20-minute summary of what I learned from this, my takeaways, and what I think people should start actively doing, to protect themselves and to inform others. So I hope you enjoyed it, and I'll see you next time. Bye.